Hello, Yusuf. Hello, Sandura. Are you with us? Can you hear me? Can you see?
Yes, I can hear you.
Yes,
Thank
I can
you.
hear you.
Perfect. So, okay. So, I guess we're going to start, and people should join within our presentation. So, um, today's session is all about how we can build risk models, or how it's the main concept of building risk models. What it does it need to build it, and also we're going to learn why do we build it, and what is the outputs of it, and how we can use it to support our decision making. Because the main essence of risk management for us is building risk model, building risk-aware decisions, rather than just quantifying risk. It is just knowing what the best decision to take. So that's what we're going to learn today, and I hope you like it. So I guess, can you just, Nicholas, how are you? So can you just let me know more about you before we start? So can we start with Nicholas?
Yep. Hello.
Hello.
Just getting the camera. Hello. How are you doing? Yes. Hello everyone. So I've been in information security for quite some time. I'm a senior risk manager. I've been working in the insurance industry for the last couple, 2 or 3 years. Um, I have some exposure to fair risk, quantifying risk. I've always had it's always been a bit difficult to get people to understand it. I've found. So I'm definitely kind of engaged right now to try and see if I can make it work, which is what kind of got me interested in what you're doing here. So yeah, hi everybody.
Hi. That's really great insight from your side. And for you, Yusuf, can you tell us more about you?
Hello, thank you very much for Rami Salim hosting this session. My name is Yusuf and I'm from Netherlands. I'm coming from maintenance and reliability background. I've spent all my 22 decades of experience in oil and gas and asset intensive sectors, doing strategic risk assessments to very asset specific risk assessments, including Monte Carlo simulations. I would like to hear from you. Something always eager to learn new or relearn new things. That's always my interest. Thank you.
Perfect. That's great. And Sandura, do you like to present yourself?
Oh, yes. Good day. I'm Sandora. I'm from Suriname, South America, and I'm working at a bank, Islamic bank in Suriname, on the risk department. So I was interested in this session in order to improve my work.
Perfect. And we have here also Sav Ricci. Can you tell us more?
Hi, this is Rishi. I'm currently based in the UK, but I've worked on international projects as a program risk manager. But like to learn more about quantifying risk and for schedules and cost. But pleasure to be here. Thank you.
Thank you. And Sarvish.
Yeah. Hi everyone, Sarvesh here. I'm from the UK and I work as a risk consultant with a consultancy company. And I'm quite new to risk management and thought it would be helpful for me to learn some quantitative risk management and the modeling. So thank you very much for this session, Rami, and looking forward to it. Yeah.
Perfect. Abdul, last one. Okay. So let's start. Let's start. I guess people are joining. Um, so I want to give you more background about myself. My name is Rami Salim. I'm basically a risk management consultant. I work with IQRM, and also I'm a consultant for several major oil and gas companies like Saudi Aramco, ADNOC, and others. Mainly, I do consultations in terms of um, facilitating risk workshops, and also doing quantitative risk assessments for major projects and major decisions like investing decisions, like such decisions to help them to take more risk-aware ones. So to reiterate what I have said before, the main objective of this session is just to give you an insight how we basically build any kind of risk model, not specific for any industry, but as generic as possible, so you can relate to your own industry to it. Because I know that most of you are from different backgrounds, so that's where we are coming from. And so let's start our presentation. And to your information, this is a recorded session. If you have any problem with this, please let me know. So just for you, and it can be reposted later on LinkedIn and other social media stream. And so first thing is, why do we need risk model? So why do we need risk models is a very crucial question, because risk model can be a waste of time if we don't know why we are building it for. So we build it to help the decision maker to understand the different scenarios that may occur. Because usually when we are needing a risk model, that means that we are having a lot of uncertainties regarding the work environment that we are in, or regarding a decision that we are taking, or regarding a new venture that we are heading to. So we need to understand how it's going to affect us in a way or another. So that's why we need to understand um, the the effect of what is the effect of our decision on the final outcomes or the final objectives. For example, we're doing a new venture investment, and we need to know what the expected outcomes from it. What's the probability that we're going to lose money? What's the probability that we're going to make profit? How what the maximum profit we can be achieving? What's the most likely profit we're going to achieve? um, if we're doing this for a project, so what's the expected delivery time for this project? What is the the latest time that can be delivered at? What is the most likely, for example, what is a 90% confidence level that we are going to deliver this project date? And even for its budget, whatever, also if what the probability that we're going to make profit in this project or not, or maybe even making losses. So all of this kind of uncertainties of the future, it is related to a lot of what we say uncertainties in our inputs, in our building up of our decision making. So building a risk model is, instead of just what we say gut feeling assessment, we try to put all of our inputs, all of our insights, all of our available information as much as possible into a single risk model. And we use what we use in this demonstration is using Monte Carlo simulation. So that Monte Carlo simulation model is more about how to it's a well-known method to interpolate what is the different scenarios that we do have, and we're going to have an overview how it looks like. So how it is built. So whatever the risk model that you are building, whatever the thing that you're building up, it has there is certain inputs you have to provide. That's whatever what I'm building. If I'm building for an investment, if I'm building it for a project cost estimate, if I'm building it for a schedule, whatever it is, the inputs are the same. The type of inputs are the same. Maybe the names of the inputs are different, but the type of inputs are the same. So, for example, as I said before, what we are doing, we are looking for uncertainties in our inputs to try to model it up to see how the different scenarios looks like. So we can have an overall experience of the different scenarios and see what may go right and may go wrong. So the first thing we need is we identify the uncertainty in our inputs. We are looking for uncertainties in our inputs. We try as much as possible to find out what kind of uncertainties that we do have, and we try to see what is the, for example, the estimated range for it. So, for example, if we're looking for a schedule, for example, when we're doing a planned schedule for a project, we have the activity duration. It is what we have setting for as a plan. It is uncertain. For example, we say the excavation works take 2 months. How certain are you in these 2 months? 2 months can be 3 months, can be 1 month and 15 days. So it's a range. So this kind of uncertainty is here. And even if you're going uh, to, for example, make an investment, and we're saying the estimated cost for the capital cost or the capex of this investment ranges from uh, $1 million to $1.2 million. So it's also some sort of uncertainty how much I'm investing and how much I'm uncertain about my investment. So it's also anything. So what we try first to do is we try to capture as much as possible the uncertain inputs that we do have in building up our decision, and we make a list out of it, and each one of them we start putting its estimated range of values. We try to put it, for example, its minimum, its maximum, its most likely, its worst case condition, whatever is the type of information or data we need to have or we do have available. Sometimes we do have the most likely value and the worst case scenario. Sometimes we do have the minimum, the most likely, and the maximum values. Sometimes we do only have a minimum and a maximum value. So every time we do have a different, maybe a combination of inputs or a range of uncertainties. So it doesn't matter a lot because every one of this kind of combination or inputs, we had to we deal with it in when we are trying to select the second point, which is our probability distribution. So the probability distribution, I would like to explain it as it is the algorithm that we tell the model how to deal with this kind of input. So when we telling it, okay, this is the minimum value that you're going to face for this input. This is the maximum value that you're going to face for this input. And this is, for example, the most likely input that you will have. So it's just teaching the model which is which, and also depending on the type of input we do have, the availability of information that we do have, the maturity of the data that we do have. It depends on which probability distribution we should be selecting. So it can be, for example, PERT, can be triangle, can be log normal. It depends on each one of these. And afterwards, we do have something called correlation. So you should realize that all the inputs are related to each other. So there are some, not all of them, but some of them or most of them, depending on the kind of situations that you have. For example, if we talking from projects perspective or from IT perspective, if you have uh, like high risk for like going to have an intrusion on your system, so most likely going to lose data also. So there is a correlation that the more the variability, the more of the more your system are not secured, the more possibility of losing the system data. And also, for example, for projects, for example, the more we're going to have excavation quantities, that is maybe related to more backfilling quantities. So that also may be another correlation between different inputs. So that we may identify between some inputs and each other, and that we can use to see more about how it's going to impact us uh, in our risk model or in our scenario. So the main priority when we are collecting this data, we are trying as much as possible to be reliable, as like we try to benchmark it to previous historical data. We try to use subject matter expert opinion. We try even to validate the subject matter expert opinion inputs to make sure that their inputs are really reliable and making sense. And using correlation is another way to have more realistic modeling or more realistic relationship between the inputs and each other. So when we are trying to search for the outputs or looking for the outputs, we having a more realistic output and dependable to take more risk aware decisions. One second. So So after we do this, we merge the three of them into our risk model. We put our we put our uh, we put our estimated range of values, we put our probability distribution and correlation into our risk model. And so this depends on how the estimated range of values depend on the information available, the data that's available, the assumption has that have been made, and the probability distribution is selected based on the quality of the data and the information, the also the assumption that been made, so that we use the most appropriate probability distribution. And also for the correlation, we try as much as possible to select the make do the correlation between the inputs that are related to each other. So after this, we do this for each kind of input. We do the estimated range, the probability distribution, the correlation for each kind of input. And we put all of this in what we call a Monte Carlo simulation engine. So a Monte Carlo simulation is basically a method that explore the different scenarios. For example, we tell it to do 5,000 iterations. 5,000 iterations means it will do 5,000 scenarios. And these 5,000 scenarios will work on the estimated range that we have inputted for, the also the probability distribution that we have selected, and the correlation that we have been made. So it will understand from this which kind of probability, what kind of different outputs we're going to have. And it plot out something for us like this, which demonstrate the different outputs that we have. So it is every scenario, it select a random selection from the estimated range of values, but taking in consideration the probability distribution that been set to it, and also taking in consideration the correlation that we have set between the different output, different inputs. So from this, it learns where is the different outputs are, and the outputs for us can be the total cost of the project, for example, or the total um, or the IRR or ROI for a project investment, or can be whatever objective that we are studying. For example, the delivery date for a schedule. So whatever the objective we are studying, it is uh, it is the output of this model. So it gives you a range of outputs, as you see here. It is a range of output, and it may be based on the very optimistic scenarios. It would like be a small one. So, for example, if this is a cost estimate, so very optimistic scenarios, the values will be very small, and that like the x-axis here represent the objective output. For example, for us, it will be a cost estimate. This will be the estimated cost for a project. So if it's a very optimistic scenarios, here is the output for example, for the very optimistic scenarios, and then we have the outputs here for the very pessimistic scenarios. So all of this, it is represented here in our using the Monte Carlo simulation model. So is this enough for us to take a decision? Not yet. We need to analyze the outputs. We need to assess it to understand it more and get better idea about it. So that's why we need, for example, to look at it. This is what we call a probability density chart. That said, for example, this is the range of output that we have. For example, here we're studying a profit of a project. So this is the range of the profit of the project, and where it is plotted. This is a minimum profit that we have, and that's the maximum profit we are expecting to have also. So that's demonstrating the different scenarios that we have. So, for example, if we're looking at such a chart and we saying what is that from this chart, we need to understand what is the expected profit that we're going to be making. So from this, if you can say that we had a 90% chance from this chart that our profit will be ranging from $50,899 and our to up to $159,000. What does this mean? That means that out of the 5,000 scenarios, there is 4,500 scenario that its output are within this range. Its output is within that range that we are saying. So we are saying that our profit, we are 90% sure to translate this to something can be understandable, that we are 90% sure that our profit will be ranging from $50,000 up to $159,000. Okay, so in other words, and also we only have 5% chance that we are having a profit that is beyond 159,000. In other that would, and why we saying so? Because only 5% of the scenarios it is beyond this value. So that's why we're saying we only have 5% chance to be beyond 159,000. And the same goes if we're going to make a profit that is less than 50,000, we only have a 5% chance we're going to have a profit that less than $50,000. So see, we from this Monte Carlo simulation, it exploring with us all the different scenarios that we're going to have, and each scenario is having its own output. And from this chart, it can help us to understand where do we stand and where it looks like. And we can compare this with our target, for example, target profit that we need to achieve or the target value that we want to achieve, and see what's the probability of this target profit to be achieved, or what how much we should consider that it's like a contingency. If we're talking about cost estimate, for example, how much contingency we need to add to maintain our profit. So to be, for example, 90% sure that we are confident in this output. And so if we, and before we explain this, I would like to explain to you something else that is very helpful when we're building models. So usually the model is built based on maybe hundreds of inputs. So to identify the inputs that really affect your model outputs, we use something called a tornado graph or tornado chart or a sensitivity analysis. This sensitivity analysis is used to demonstrate for us how how each variable affect our uh, output. and particularly which inputs are the most impactful to our risk models. So the top ones here, it's the most impactful to our work model, to our risk models, and affecting it much greatly. That means when I'm studying this risk model and I want to reassure the information and data, I will get back to this tornado chart and check if this does make sense to me, and also based on the inputs I have been provided. And if this, for example, is very influential and does make sense, then this is one that we need to tackle and put some sort of response actions for it. We take some sort of decisions to maybe lower its uncertainty or lower its impact on our project. So it will have a lesser impact on the success of our investment, the success of our project, the success of whatever objective that we need to achieve. So the tornado chart is very, very useful when we are needing to investigate our risk model to make sure that it is right, not wrong, to make sure that it's valid, to also understand where to focus, where we should put our efforts on, which inputs or variables that we need to focus on, and to study how we can deal with it. So back to our density chart. For example, here, uh, if I want to say what's the point that would be 95% sure, if we're talking this about like because I know it's the same chart, but if we assuming this is like a cost estimate chart, and we want to say which point here will be, uh, we will going to have a 90%, 95% confidence level that we will not be surpassing this point as a cost estimate, like an estimate for a project. So from this example, we have this this range is covering 90%, and from 0 to 50 is other 5%. So when we're saying 159,481, it is covering if we set our output, our estimate as this value, then we're saying we are 95% sure that we are not going to exceed such cost estimate. And it then we can return back and see how we our base estimate can be. Maybe our base estimate is just 130,000. So then we have a contingency of like 20 of almost 29,000. So that's how we calculate our contingency. We compare our deterministic estimate with our probabilistic forecast for how it's going to look like. So, for example, for this example, we're saying our P80 value, we're assuming that our P80 value is something within here that we are going to have here, is like 145,000. And our deterministic estimate, like what the cost estimator have done, whoever who is responsible for the estimate says, our base estimate based on our database or based on our offers is 130,000. So to calculate a contingency, we will say the contingency, if I want to be 80% confident in my cost estimate, I will take it to 145,000 and subtract from it the 130,000. And then we say our contingency is 15,000. So that's it. So that's 15,000 is my contingency that I'm going to add to my cost estimate to make sure that I am 80% confident in my estimate, in my like this project that I'm not going to. I am only I'm not going to have. I only have a chance of 20% that I'm going to exceed this budget or this estimated value. So for this, I have like given you my overall review about what is how we build a risk model, why we build the risk model, and also the different insights that we look for in such risk models. And also one of the insight maybe I want to tell you about, for example, if our estimate is 130,000, I'll be looking for something like how much what we call what the percentage that we are going to achieve this 130,000. And let me also maybe give you a quick uh, look at it in action. So we can open Safran. So far, do you have any questions before giving some sort of an example how it looks like? Any questions? Okay. So I'm just waiting. Uh, so I will share with you my screen here. So I'm loading something called Saffron Risk. It's a risk management software for projects, and I just wanted to give you a quick overview how it looks like, and just understand basically what a risk model is. And the same goes if we're going to make an investment risk model, if we're going to make a whatever risk model. But this is maybe specific more for projects, so you may be keen to look for it. Just loading. So basically, here we have a schedule. We have a schedule for a project, and this schedule for a project is that we use a typical project that, like for example, a planner or schedule that have developed, and we are not sure when we're going to finish our project. Then we have, for example, project risks. So just loading. Just opening up. I don't know why it's taking time. So, for example, we have this kind of risk values. So we have, like for example, that's an input that we usually classify the activities. Is it aggressive duration or conservative duration or realistic duration or very aggressive and so on? And we say, okay, this duration can be, if we say aggressive, that means that it can be less by 5% than the original duration and can be more by like 125% than the original duration. And we have here like a triangle distribution that we are using. That's different probability distribution. That's another story to tell you how to select the best ones. And same goes for each one of this. Then we have, I hope it loads up. I don't know why it's not loading up. Okay, it's weird. So we have here the risk types. We have probability. Also, we have another thing that we have risk items. So not only uncertainty that we are modeling risk events. So what's the difference between an uncertainty and a risky event? That when we say a risky event, that means it's something that may happen or may not happen. So, but when we're saying an uncertainty, that's something we are 100% sure that will happen. So that's basically the difference. And here we list all of our risk events and uncertainty that we do have. And we do the correlation, we do the mapping, and we map it, for example, for our schedule, and to make sure that everything is mapped correctly to the considering risk model. And here in Safran, there is something called integrated cost and schedule risk model, but this is not our subject for today. And here is the correlation matrix. We set from the correlation matrix the relationship between the different inputs and each other. It's just loading. That's what we can load. And here we tell it we're going to, for example, run a risk a simulation. We can make it 1,000 to be fast. So we say I want to do 1,000 iteration, and we want to run a risk model. I don't know why it's crashed. Okay, it's crashed. What's the problem? It's a bit heavy software, but I'll try again. Or we can actually work with Primavera risk analysis. This one is a little bit heavy. So this is Primavera risk analysis. It's also another software. We can open recent. And we also have here a schedule and everything set up. And we have, we can say, duration, quick risk. So we say here we have like a minimum duration for each activity, a most likely duration, and a maximum duration. And then we set, for example, we say we want to make 1,000 iterations. So here it's like 1,000 iterations that we have made, and this tells us that from here we can understand differencing that. For example, our the planned date that we're going to finish the project has only 50% chance to be achieved. And there is 80% chance that we're going to finish before or on the 11th of February 2008, because this is like an old example. And so from this, we can say how we're going to achieve, like, I want to increase the deterministic value from 50%, for example, to be 80% or 90%. So from this, we start to navigate, for example, our tornado chart and see what the activities have been affected the most. And we start navigate from this and to understand how we can lower this to a lower value, or how we can deal with this to make sure that we achieve for example, the 80%, and see the decisions and how much it will going to cost us and so on. So this is just a quick overview about uh, the how to build a risk model, either for what we call a schedule, or even maybe I don't have now. I didn't show you any investment examples or something like that. Maybe later on I'll be showing some sort of like more like investments, but maybe not now. And basically how this is how we build up a risk model up to the end, and this is the output that we look for. And so, can you tell? Did you like this session so far, or you have any feedback, any questions I can help you with? So guys, do you hear me?
You can continue, Rami. I think you're going well. Thank you.
Thank you. So, I finished today, and I would like you, if you want to have a more in-depth understanding about how to build a risk model, we do have a workshop that, for example, if you're interested in learning about the integrated cost and schedule risk assessment models using Safran Risk, it's a 2-hour session. It will be 1 day session on the 7th of September. And also that we have a full integrated course called QRM. This is QRM. It's a 12-hour course. It will be on 6 sessions that will be started from the 15th of September. And this will be in-depth learning about quantitative risk assessment, Monte Carlo simulation, risk reporting, and more. So this is if you are interested in like in-depth learning about building risk models, that would be the way to go. And if you're only integrate little interested in schedules, risk models, that may be a good option too. And I'll be putting in the comment section, I'll be putting the links to enroll in each one of them and the relevant post, so we can have you can have access to it. So let me see where the comment section is. Yes, chat. So here it is. So let me know if you have any questions so far. So Yusuf what's the high level limitation of MC simulation? What do you mean by high level limitation? What do you mean by this? Can you explain?
Uh, yeah. Are there any limitations for the Monte Carlo simulation in terms of data, in terms of any prerequisites that you want to explain?
Yeah, it is mainly that you have to have either a subject matter expert with you that provide you the data, or you have historical information that you build on, or but it cannot be haphazard information. If it's very haphazard and all the inputs are maybe one input can be like low quality or low input, but not all the inputs having low quality. So you have to do because Monte Carlo simulation, what it do, it's a sampling model. It do like it takes samples out of what you have inputted for it, like the estimated range, um, the the curve that you have been the probability distribution have been provided. So this is very like relatively all of the information very low, it will not be useful. So as much as possible, you get subject matter expert information data. You start benchmarking to historical information, and reasoning can be also way to like try to set, for example, set an assumption and build on it a certain model. For example, if you would say that's the assumption that we're going to follow on this risk model, and this will be part of your risk report. Okay, Robert, it will be recorded. I will be putting it on YouTube, this session. The full session will be on YouTube. So, yes, it will be recording and uploaded on YouTube. Any other questions? So, who here is from like from enterprise background? Can you raise your hand if you're from enterprise background, like enterprise risk management background? Okay, Robert, and perfect. And who is here from project controls, like schedule planning, uh, co-estimate background. That's the okay, Richie. Perfect. So, do you have any other questions that I can help you with? I would love to answer. Okay. It was really nice having you all here, and I hope you have enjoyed this session. And I hope you to join my next ones. And thank you very much.
Thank you very much. Thank you.
Thank you, Rami. Very good. Really appreciate it. Speak to you soon.
Thank you.
Take care.
Thank you.
Thank you very much.
Thank you.